everyone. Welcome to the 5th annual Esri UC Science Symposium. And a special welcome to those of you who are joining so very early in the morning in whatever time zone you're in there. For all of you, we very much appreciate your dedication and support of this event. And we're going to do our best, even in this virtual format, to make this an event to remember. So let me first start here by sharing my screen, and we can get started here because I have some preliminary announcements before we welcome our keynote speaker. The first very important announcement is, yes, this session will be recorded, just to reassure you, and it will be available within 2 hours after this session, including the Q&A portion that we will capture. And for the rest of the world, a recording will be available sometime in the future, likely around September the 1st. First, by way of introduction, I'm Dawn Wright, Esri's chief scientist and also a full professor of geography and oceanography at Oregon State University. As chief scientist, I foster a program at Esri to strengthen the scientific foundation for Esri software and services, especially in the disciplines shown, where we have a very strong scientific expertise and productivity here ourselves. And you can see that weather and climate is highlighted because that will be the emphasis of today's session. And I also represent Esri to the national and international scientific community on various boards, councils, and research projects. We also work collaboratively with some of the world's largest earth science organizations, as well as amazing individuals such as our keynote speaker. One reminder is that many of you are aware of our Q&A, which goes live before the conference, but I want to let you know that this is a fabulous reference to have at any time. So I encourage you to check out the current Esri UC 2020 Q&A because it's one of the single best sources of information on Esri as a company, including our products and services, and it's based on your questions. So it's still available online and searchable at the large link in purple. And what you're seeing here is the question about geographic science. But the answer to this question focuses more on the specific ArcGIS software capabilities and tools for scientists. And then there's also a terrific summary of the entire Esri UC Q&A that was done by one of our users, Chris Jeps, the COO of Expertat Consulting in London, and his work is in the smaller URL there. And I hope that you're feeling free to take screenshots of these slides. I'm also going to share them with you at the end of my introduction. Now, I know that many of you are Twitter users, and for you, Twitter is your preferred discussion forum. It may be your place to get news and content as well. So we want to let you know that we have a popular presence on Twitter at GIS and Science, or you can follow me as well. Though be warned that if you follow me, you'll get a lot of GIS and science content, but also a lot of content about Legos, professional cycling, and the adventures of my puppy dog, Riley. We also have been working very, very hard on our online science portfolio, which continues to evolve at esriurl.com/scicom. There are other ways to get to this site, but this is a shortened URL for you. It's also the subject of a new column that I have in this month's ARC News. This site continues to focus on our 6 major initiatives as we contribute to the scientific community. So there's open science, there's a section on weather and climate science. We have an initiative on ocean science, solid earth science, and that includes hydrology, agricultural science, geology and geophysics, terrestrial ecology, soil science, anything that has to do with the surface or subsurface of our planet. Geographic information science is also now known as spatial data science, and that includes remote sensing, cartography, other types of the information sciences, including now there's information on the site about our new relationship with the Group on Earth Observations, or GEO, as well as the Marine Biodiversity Observation Network. We have a very important initiative on social science that now includes a major section on the coronavirus and also racial equity and justice. One thing about the site now also in its new evolution is that this is the only place in the Esri.com ecosystem where you can get to our new environmental and sustainability statement. This is really exciting. It's really important to us because on this page, you'll see a glimpse of what's been going on behind the scenes at Esri in terms of our new strategic plan, our projects, our performance reporting, especially as we continue our relentless reduction of our greenhouse gas footprint as a company. We've been delayed in some of this mission because of COVID-19, but look for much more information in 2021, and it will appear on this page. Hopefully you've had a chance to go to the Esri merch store, and there are several books in the store. Many of them are science books from Esri Press. They're scientific monographs, textbooks. Cartography is still an instant classic. That's available in the merch store. And last year, we had the great pleasure of introducing and announcing the publication of the new book, GIS for Science, Applying Mapping and Spatial Analytics, a special book that was commissioned directly by Jack Dangerman himself. And it's been a really great pleasure to work on this with my co-editor and lead layout designer, Christian Harder, as well as all of the staff of Esri Press. We were actually taken aback a little bit by the praise heaped on the book. And I think part of that was due to its somewhat unique format, because the book is not just a dry research monograph. It's not an atlas either. We are seeking to have a cross between Wired Magazine, National Geographic, and Scientific American. And Volume 1's issue had 12 stories written by top-rated scientists about how many things GIS, including geospatial data science, are a force multiplier for great science writ large. So the book is resonating with several different audiences, such as the great journalist James Fallows, which gave us this feedback. So for this Science Symposium, we're very pleased to introduce to you Volume 2 of GIS for Science, with 12 more stories that are spread across the 3 sections of the book. One section is about how the Earth works. Another section is about how the Earth looks because of our influence on the planet. And a third section is about how we look at the Earth due to our ability to observe the Earth through satellites, drones, and other means of Earth observation. There are also 12 more vignettes on Esri's own contributions to science. And this year, there is a special section on the GI scientific response to COVID-19. So as a special treat for those of you who are with us today for the Science Symposium, we want you to have a preview edition, a pre-release of this book. So if you will take a screen snapshot now or take note of this URL, this is where you can download the pre-release of this book in its entirety. The file that you will receive is in EPUB format, so that works with any standard ebook reader. But we ask, though, that you not distribute this file widely after you download it, as we're still working on the final version of the book. Basically, what you have now is an uncorrected proof, but it's near final, but not quite there. We're going to be releasing this book officially on sale in both print and e-copy early in the fall. But please enjoy this pre-release just for you as a reward for joining us in this Science Symposium. And if you're not able to get this URL, I'd be happy to put this slide up later. Something else that we are still hearing quite a bit about is the flip book that Jack mentioned in the plenary. This is a flip book that is based on the Part 4 Technology Showcase of Volume 2 and the Part 5 Technology Showcase of Volume 1. You can also access this flip book. This is completely free. It's not a download. It's just a web experience. So when you go to this URL, you will be able to flip through those sections of the book, which again focuses on innovations made by Esri staff. And then public and live and completely open right now is the book's complete companion website at gisforscience.com with literally hundreds of data sets, web maps and apps, story maps, videos, GIS workflows, many of them encased in Python notebooks, journal articles, learn lesson tutorials, and much more. So this should be extremely valuable as a supplemental teaching and research resource. So there are supplemental resources for each of the chapters here in Volume 2. And then it also still includes the resources from the chapters of Volume 1. So please enjoy gisforscience.com. So we're finally to the end of the announcements here, so we can get to the heart of the symposium. Many of you have enjoyed live tweeting this event, so we ask that you use the hashtags in the upper right, hashtag Science Symposium, hashtag EsriUC. And if you would like to download the slides that I've just shown you, you can download them all now at esriurl.com/symposium20. This event has really been a labor of love for me and my colleagues at Esri. And for the first 3 years, trying to get this event on the radar screen of Esri and getting it embedded into the program, we followed a format where the chosen keynote speaker was not a GIS specialist by design, but a noted scientist with a strong, compelling vision for improving or protecting the planet, along with a healthy respect for geospatial technology. Then we followed these keynotes with a conversational reaction panel that was deliberately made up of GIS specialists so that they could respond to the vision of the keynoter from the perspective of geospatial and discuss further how best to use GIS to implement the vision laid out by the keynote addresses given by Margaret Leinen, the director of Scripps Institution of Oceanography, John Foley, the executive director of Cal Academy at the time. He's now the executive director of Project Drawdown, and Camilla Mora, the star geography and climate scientist of the University of Hawaii. Then last year, we went to a different format where we featured a tag team of 2 top scientists with deep GIS expertise and speaking on the topic, Science in Service to Society, Understanding and Reducing Climate Risks, which led straight into question and answer with no panel that time, especially since we found out that we were running out of time for beer and bubbly and other wonderful networking. So this year, of course, we are virtual and we are missing that face-to-face wonderful networking. But I couldn't be happier to introduce you to one of the most exciting and compelling speakers in the world, whether in person or virtually, and that is Catherine Hayhoe of Texas Tech University. I was first introduced to Catherine virtually by way of her appearance on PBS Nova about a decade ago, and she was in a great episode entitled The Secret Life of Scientists and Engineers. So tons of fangirling and follows on social media by me later. We finally had a chance to meet in person in 2018 at the largest Earth Day event in the world, which is known as EarthX in Dallas, Texas. And it was as if we had known each other for years, perhaps in part because we were both born on the same day, but likely due to our common bonds as scientists and with a Christian faith. We also appeared together last year in a short film series entitled Let Science Speak, which seems enormously appropriate given the state of the United States at the moment. To fully introduce Catherine and all of her many accomplishments would literally take up the rest of our time. And there's more info on Catherine in the slide deck that you can download. So let me just say that she holds an undergraduate degree in astrophysics from the University of Toronto, an MS and PhD in atmospheric science from the University of Illinois at Urbana-Champaign. She's the current director of the Texas Tech Climate Science Center, but she also holds an endowed professorship in the Department of Political Science at Texas Tech. Now, why political science, you say? Well, as she explained recently on Neil deGrasse Tyson's new YouTube program, Star Talk, climate change is the most political science there is. So she's been on stage with many luminaries straddling this very important nexus between the sciences. With President Barack Obama, she's been quoted in the Rolling Stone. She's been a lead author on the 2nd, 3rd, and 4th U.S. National Climate Assessments. She's everywhere. The New York Times has dubbed her the climate explainer, as she is indeed one of the most trusted and quoted voices in the world on climate change. So we are very, very proud to have us with her, to have her with us this morning. So Catherine, take it away. Welcome and thank you so much.
It is great to be with you here virtually. And as a climate scientist, I know how important data is. But also as a communicator, I know how important data is, and it's important in a bit of a different way. So that's what my talk is going to be about here. So let me go ahead and begin to share my screen with you. And we're going to do something fun. We're going to talk about what the first step is to tackle climate change. But before we start talking about that, based on data, the first 700 people to respond, it's a little contest here, are going to be able to answer a few questions. So if you are on your computer, which I assume you are, or your phone, you can do it too, go to pollev.com/myname, which is spelled with 2 A's. If you do K-A-T-H-E, it won't go to the right place. So pollev.com/Catherine, K-A-T-H-A-R-I-N-E. And the first question is, where are you joining us from? Click on this map to show us where you are tuning in from around the world. And we should be able to see some dots popping up when people tell us where they're from. Not seeing dots happen here. Oh, here we go. It just took you a little while to get there. All right. So pollev.com/Catherine. And then you can just click or touch if you're on your phone or on an iPad where you are tuning in from. All right. I see one compatriot from Canada. There we go. Oh, I see quite a few. Maritimes, Ontario. Looks like Quebec is represented there. We've got the UK and Portugal. Excellent. We've got a lot from the US. Oh, Hawaii. Good. Algeria. Nice. Excellent. Oh, we got some from over in Indonesia, Australia, New Zealand, a couple in New Zealand. Somebody is in a ship off the coast of Brazil. Oh, they just changed their mind on that one. A bunch from the Caribbean. Excellent. This is fantastic. I'm somebody who prepares climate data. We're working on a brand new climate data set right now of future projections. And so far, we're looking at all the different weather stations in North and Central America, but we're hoping to expand that globally to provide data to the world. All right. Now, second question, ready? Here we go. That was the warm up. The second question is, are you in industry, academia, nonprofit, consulting, or other? It looks like we have a strong presence in industry with academia and other following up. Oh, other is taking, this almost feels like election night. I think that other might win the day. That's fantastic. All right, industry was a bit quicker off the mark, but then other caught up afterwards. Okay, so this is how we're going to do it occasionally as we go along, just to make sure you're paying attention. But now I want to start talking about the first step to fixing climate change. Often, when you talk about climate change, the first thing you might think of is smart thermostats, LED light bulbs, and recycling. These are often the things that our mind immediately jumps to when people say climate change, how do we fix it? And these certainly do make a difference. LEDs use 90% less electricity than normal bulbs. Smart thermostats save us money and energy. Recycling helps because we don't have to dig up the raw materials to make it in the first place. But did you know that We already cut 570 million tons of CO2 per year. This is our first fact. By using LED light bulbs. It's as if we shut down 162 coal-fired power plants around the world. That sounds like a lot. But global emissions of CO2 are over 33 million tons. So our LEDs have just fixed 1.7% of the problem. We need more. As my colleague, climate scientist Michael Mann said, he said, we don't need to ban cars entirely, although public transportation, carpooling, telecommuting is certainly a smart way to do it. We need to electrify them with clean energy. We don't need to ban burgers. We need to make them climate friendly. Also, the real price instead of $2 burgers. And a single scientist or even hundreds of scientists choosing not to fly again is not going to change the system. What we really need is policy change. Now, I don't know if you remember, but 5 years ago, the world went to Paris. I was there standing on that building looking at that sign when every single country in the world, including the US, signed an agreement saying that they would hold global temperature to at least 2 degrees Celsius warming and 1.5 degrees warming if we could. The Climate Action Tracker tracks where we are. And according to their latest update, which was 6 months ago, we have already seen a 1 degree Celsius warming since the beginning of the Industrial Revolution. Most of that has occurred in the last century. We want to keep warming in the yellow zone on the thermometer, which is between 1.5 to 2 degrees. But our current global and system-wide policies only keep us to about 3 degrees, plus or minus some due to scientific uncertainty. And frankly, it's more likely that we're at the top end of that range than the bottom end of the range. If you break it out by country, according to the Climate Action Tracker, if you break it out by country, they've color-coded the countries. So the ones that are doing well are green. You can barely see a few green ones on this map. The ones that are compatible with 2 degrees Celsius are yellow. There's a few more of those. Ones that are working their way there, but that are insufficient is orange, including my own home country of Canada, the UK, Europe, Australia, Brazil, Peru, and Mexico. Then we've got highly insufficient, which includes China, South Africa, Argentina, and Chile. And then we've got critically insufficient. And I think we all know who that includes. So at this point, you might be saying, well, why are we not acting? Why are we not doing what it takes? What is the first step to climate action? And often, and this cartoon is actually from one of our global weirding videos on YouTube, often we say, I know why we're not acting. It's because people don't understand enough science. That's why. If people understood the science, they would be able to understand why we need to act now, because the facts are very clear. So if that's the case, if people don't understand the science, the answer is clearly more science. And don't get me wrong, I am a big fan of science. One of my very first memories actually is my dad, who was a science teacher, taking me out to a park at what seemed like the middle of the night. It was probably about 9:30 or 10, and teaching me how to find the Andromeda Galaxy through binoculars. When it comes to the science, we have a lot of science. We have science that shows us that global temperature, the black line here, goes up and down from year to year, but decade by decade, it's been ticking steadily upwards. We know that according to natural factors, the blue line, our temperature should be just going up and down very slowly and eventually gradually cooling due to natural factors. We know that only when we include the human factors, which is the red line, only when we include the human factors together with the natural factors, the blue line, do we get the orange line, which tracks what really happened. So we have the science showing that yes, climate is changing and yes, humans are responsible. And we know, and these are just headlines from the last, couple of months, we know that things are getting worse. Climate change is affecting wildfires. Greenland and Antarctica are melting 6 times faster than the 1990s. Our methane emissions, methane is the second most important heat trapping gas after carbon dioxide, our methane emissions continue to rise. If you go to Google Scholar, where scientific research is archived, if you go to Google Scholar and you type in climate change in Google Scholar, you will get 2.6 million results. Each of those is a scientific study. 2.6 million scientific studies. So the scientific literature has the facts. There is no question about that. 6 IPCC assessments of 3 volumes each, that's 18 of them, they have the facts too. We have 4 national climate assessments in the United States and 1 in Canada now too, 1 in the UK, several in other countries. They've got the facts. In fact, I was a lead author on the 2nd, 3rd, and the 4th National Climate Assessment, and the 4th National Climate Assessment in the United States was so big that it got broken out into 2 volumes. The first volume was 500 pages. You can find it online at science2017.globalchange.gov, and it is currently the most up-to-date assessment of the state of the science until the next IPCC report comes out. So even if you're not in the US, this is a great resource. You can go ahead and take a screenshot like Dawn was recommending. Volume 1 was 500 pages, and then volume 2, which talks specifically about every region in the US and every sector in the US, including the oceans, the islands, and the Arctic. Volume 2 was 1,600 pages, and you can find that one online at nca2018.globalchange.gov. Esri, of course, has the facts. This is a fantastic story map called Hot Numbers. And if you go to Hot Numbers, it scrolls through the facts on climate change. It shows us how carbon dioxide levels in the atmosphere are at their highest level in, it's actually not 650,000 years, it's actually 15 million years now. Need to update the story map. We know that our average temperature has increased 1.8 degrees Fahrenheit or 1 degree Celsius. We know that every 10 years, the extent of Arctic sea ice declines by almost 13%. And these facts have been communicated by thousands of scientists. This paper that came out, it seems like 3 years ago now, but it was just this past January. This paper that came out in this past January was signed by 11,000 scientists, including me, warning of a climate emergency. 11,000 scientists. And we've been communicating this over not just decades, but centuries. These are the pictures of the real scientists who built the basis of our scientific understanding of how climate is changing. Fourier in the 1800s was the one who identified the fact that our planet should be 30 degrees Celsius or 60 degrees Fahrenheit cooler than it is today if it weren't for our atmosphere. John Tyndall identified which gases they were in our atmosphere that keep us warm like a blanket keeps us warm on a cold night. Eunice Foote, who we do not have a photo of yet, but I'm working with the Smithsonian Archives to try to track one down. Eunice Foote experimented with different CO2 levels and concluded that if CO2 were higher at any time in the planet's history or future, our temperature would be warmer, and her work was published in 1856. Arrhenius, in the 1890s, was the first person to calculate a climate model from scratch by hand. It took him 2 years to calculate how much the Earth would warm if we increased levels of CO2 in the atmosphere, but his numbers were very comparable to our most powerful supercomputers today. 1890. And in the 1930s, Guy Callender, a British engineer, collected weather data from around the entire world to show that, yes, the planet actually was warming. And in his paper, which was published in 1938, I love reading it because it says, in essence, you're not going to believe what I have to say, but I will show you using facts and data that the planet is warming due to human emissions of carbon dioxide from industrial processes. That's how long we've known, and that's how long we've had the facts. So now I want to ask you a bit of a different question. This is a little bit harder. I want you to type in a full answer here. What is the most convincing scientific fact in your opinion? This is just your personal opinion for telling people that we need to fix climate change. And here's the cool thing. You can either type in your fact, or If you look at the app, and you can do this again on your phone, or you can do this on the computer at pollev.com/Catherine. If you look at the app or you look at it on the computer, you can see other people's answers and you can upvote other people's answers. So even if you don't know what your answer would be to this, go ahead and upvote the answer that you would agree with most. And this is 100% anonymous, so don't worry about it. All right, you're getting the hang of it. This is great. So far, we got a lot of great ones. These are all very good ones, by the way. I can say that officially as a climate scientist. We've got a lot of good ones, and it looks like melting in the Arctic is taking the top spot, but increasing extreme weather is catching up. And I second that, because most of us don't live in the Arctic. So when we see things happening where we live, it's often even more powerful than if we see things happening, through photographs or videos or news reports on the internet. All right, we've got though coral reef bleaching is moving up. I know that will be near and dear to Dawn's heart as an oceanographer. And then we've got sea level rise. Yes, if you live along the coast, you can absolutely see that. And I think if we combine the extreme weather with the natural disasters and the other extreme weather, I think that actually might be number one if you put those together. All right, so extreme weather, Arctic melting, glacier melting, coral reef bleaching, and sea level rise. We've also got fires, coastal communities, which is kind of related to sea level rise, and the mass extinction of species, which climate change is a multiplier of. All right, excellent job, thank you. So what would my fact be as a scientist? Well, as a scientist, I feel like we learn so much from paleoclimate data. That's data that goes in the distant past, because the number one argument that people have, and I get this every day on Twitter and social media, if you go to skepticalscience.com, they have ranked the most popular objections to climate change too, and they find the same one at number one. So both my own experience and Skeptical Science have found that the number one sciencey sounding objection to climate change is this: it's been warmer before. That's the number one. But here's the thing. When we look at the paleoclimate data, yes, it has been warmer before, but it's never been this warm during human history, human civilization on this planet. And our civilization is built for a very specific type of climate, the climate that we've had the last 10,000 years. It's never been this warm during human civilization, and CO2 levels are heading out of the ballpark into Jurassic Park type numbers. So specifically, our CO2 levels in the atmosphere are now at almost 420 parts per million, which we last saw over 15 million years ago. There weren't a lot of roads, bridges, agriculture, economic systems back then. In fact, there was none. Continued growth in emissions over this century and beyond would lead to atmospheric concentrations that we haven't seen for millions of years, tens of millions of years. And here's the biggest kicker for me. And again, this is for me as a scientist, what I see as the most concerning fact. We're currently pumping over 30 million tons of, 30 gigatons of CO2 or 10 gigatons of carbon, because CO2 is the oxygen attached. So we're currently pumping about 10 gigatons of carbon into the atmosphere every year. And as far back as we can go in the paleoclimate record, to the times when climate has changed in the most extreme way due to natural causes, at the most extreme time, our best estimates are that only 1/10 of that was going into the atmosphere every year, naturally. So in other words, as my colleague Bob Kopp and I concluded in an essay we wrote a few years ago, we concluded Aristotle might argue that humans were not responsible for the choices made at the beginning of the industrial era, when collective scientific and societal knowledge limited our capacity to choose wisely and well 300 years ago. But regardless of our original ignorance, over the last few centuries, we have been conducting a truly unprecedented experiment with the Earth's climate system, which I would add is the only home we have. We know that just like there's no magic number of cigarettes you can smoke without having lung damage, it's not as if you can smoke 9,999 cigarettes, but as long as you don't smoke the 10,000th one, you're going to be totally fine. We know that's not the case. And in the same way, there's no magic amount of carbon emissions that we can produce. If we just produce 500 gigatons total, we'll be okay, but 501 and everything's over. No. We know that there's no magic number of amount of carbon emissions we can produce to avoid all risk. But we do know that the faster and the further we cut our emissions, the better off we will all be. And yet, here we are. What is this? This is a poll done in February 2020, so just a few months ago, just before the pandemic rolled over all of us, asking people what they thought about various issues and which one was a priority for them. This is a US poll, but unfortunately, we're starting to see similar numbers in Canada, in Australia, and even in the UK. This is a poll where the red indicates Republicans and the blue indicates Democrats, and the gray bar indicates how far apart they are on a given issue. So this is a figure showing polarization of issues. The wider the gray bar, the more polarized the issues, and these issues are ranked in terms of what? In terms of how wide the gray bar is. So in other words, the issues at the top are the most politically polarized issues in the United States. And what is at the top of this list? It's not guns, it's not the budget, it's not the economy, it's not terrorism or immigration even. The number one is climate change and the number two is environmental protection. That's where we are. So this starts to explain that map we saw, remember, where the countries were color-coded, green, yellow, orange, red, and gray for insufficient action. We are here because climate change has become the most politically polarized topic. But a thermometer doesn't give you a different answer depending on how you vote. You don't get a different number if you vote conservative or liberal or Republican or Democrat or Labor or Tory. And the planet is warming, and we have checked, and humans really are responsible for that, no matter whether we agree with that or not. The Yale program on climate communication has these great series of maps for the US. They also have them for Canada, and they show by county and by congressional district, and in Canada by riding as well, what people's opinions are on various questions. I want to show you a few of these maps because they're very illuminating. What are you looking at here? You're looking at people's answers to the question at the top. Do you think global warming is mostly caused by human activities? Anywhere that's blue is less than 50% of people would say yes. Anywhere that's orange is more than 50%. And if you go to these maps interactively, you can find them by just Googling Yale climate opinion maps. Take a screenshot if you want. You can click on your county and you can actually get a printout for your county, and they have them in English and in Spanish now too. Anywhere that's orange is more than 50% of people would say yes to the question, and the darker the color in either direction, the more people would say no or yes. This is a pretty depressing map. Only 53% of people, specifically kind of out at the edges of the coast, and then down in Florida where they see sea level rise, and along the border in Texas where there's a lot of Hispanic people who are very concerned about climate change. They're one of the most concerned people groups in the US. We see strong orange, but in a lot of other places, we see a lot of blue. And then when you divide this same map up by one thing, political affiliation, you can see what it looks like. This is just showing by congressional district here because it's looking only at registered voters. This is pretty depressing. So at this point, we might be saying, all right, if light bulbs are not the first step, if system-wide solutions are not occurring because they're being blocked by the political polarization of an issue that we've understood since the 1850s, then what is the first step? More scientific data is not the answer. Tali Sharot is a neuroscientist. She studies brain activity. She doesn't study climate change, but what she studies has a lot to do with data and climate change. She says that our brains are programmed to literally get a kick out of information. We have evolved such that information is so valuable to us that when we receive new information, we actually produce dopamine in our brains. There's a physical reaction in our brains to receiving new information. That's why when you scroll down those websites and you see the little 10 child celebrities, you wouldn't believe what they look like today. Those types of things are specifically designed to trigger that desire for knowledge in our brain, so we will click on them. That's clickbait. But she warns, when we give people new information, they typically only accept it if they already believe it or agree with it, or if they're neutral about it. I have no strong opinion about child celebrities and what they look like today, other than maybe curiosity. If they agree with it already, they accept it. But if it contradicts what they already believe, their brain shuts off. So in other words, shoveling more facts about climate change to people who don't think it's real, what's going to happen? If it contradicts what they believe, their brain is just going to shut off. More data and more facts are not going to change people's minds to spur the system-wide action that we need. And in fact, Tally goes on. Dan says, and then I'll go back to Tally in a minute. Dan is another social scientist at Yale University, and he looks at how people interact with information, specifically information on issues like climate change and vaccine that people have very strong opinions about. He found in a 2012 study that he did that members of the public who had the highest amount of scientific literacy, so they knew the most science, they were best able to understand facts and data in science, they were not most concerned about climate change. They were the ones among whom cultural polarization was greatest. And in fact, Dan went on to design something he called a measure of ordinary science intelligence. So it's just one measure of IQ. This is a measure specifically of how capable people are of understanding data and numbers and drawing conclusions from them. And he found that there was a very weak correlation between ordinary science intelligence and the probability of correctly responding to the following question: is climate change occurring mostly due to human activities? But then when he took his data set and he split it into two pieces, based on what? Not age, not education, not gender, political affiliation. He split it into two pieces based on political affiliation, and what did he see? He saw that the better able we are to understand scientific data, you know what we do? The better able we are to cherry pick just the pieces of data that we agree with. It's called confirmation bias. We just cherry pick the pieces of data we agree with, and our brain shuts down and ignores the rest. So the smarter we are, the better able we are to justify our position. And we all do this. We all do this with things that we feel strongly about. Tally goes on. This is the conclusion I was coming to before. Tally goes on and she says, the wealth of information in our modern day, with the internet bombarding us on our watches and our phones and our computers and our televisions all the time, this wealth of information actually makes us more resistant to change than less. Part of it is because we have access to customized media that echoes what we already believe all the time. You don't just listen to a single newscaster anymore. You listen to whatever newscaster has the kind of approach or ideology that you agree with. And we are all guilty of this too, most of us, because it's more comfortable to do that. The wealth of information makes us more resistant to change. Why? And this explains Dan's result. Because it's so easy to find data that supports our pre-existing opinion. That's what Dan found. And of course, the smarter we are, the better we are at finding that data. But here's the real conclusion, and this kind of scared me when I read it, but it explains a lot. She says, as we are exposed to contradicting information and opinions, polarization expands with time as people receive more and more information. So as we receive more and more contradictory information and information we don't agree with, the polarization gets worse, not better. So although our instinct, when people don't agree with us, our instinct is to give them more information and more data. Sea levels rising, the Arctic is melting, our coasts are being threatened, coral reefs are bleaching, extreme weather is becoming more frequent. Although our instinct is to give them more and more information to convince them, what she says is that if people don't already agree, more information will simply make that gray bar we looked at wider. So part of the reason why that gray bar is so wide on climate change environmental issues, part of the reason is because we've had so much information thrown at us. Isn't that like just absolutely mind-boggling? So there's a vicious cycle. Here's what the vicious cycle looks like. Climate changes, which it's been doing now for quite some time due to human activities. We get worried about it. And we should be worried. So we share more scary data. We say, if people aren't as worried as we are, they don't understand the data. It is scary. We don't have to make it up. Even the real data is scary enough. So we share more scary data, but then what happens is that people reject it even more and inaction results. Because as Tally says, fear and anxiety cause us to withdraw, to freeze, to give up rather than take action. As humans, action is associated with reward. We move forward, both physically and mentally, to get something. We retreat or we stay still to avoid something. It's a very basic evolutionary response, but unfortunately it carries through to our modern day brain with the internet. So we act for reward, but we freeze when we're confronted with fear. It's a vicious cycle. And so climate change just changes more. And this cycle just spirals in until it gets to the point that we're at today, where we're just going around like this in the middle and nothing's changing. It's just getting worse. Now, at this point, you may be thoroughly depressed, but don't worry, we've reached the very bottom and now we're heading right back up. How do we break this vicious cycle? I have some thoughts. And the thoughts involve not information dumps of how bad and how scary it is, as bad and as scary as it is. And believe me, I'm a scientist, so I know. But by sharing the right kind of data. What's the right kind of data? What do I mean by that? Well, to understand what the right type of data is, we have to understand what the real problems are. We've already seen that the real problems are not lack of intelligence, not lack of scientific information, not lack of scientific facts. The real problems are twofold. Number one, we don't think it matters to us. We think climate change is a distant issue. And number two, we don't think there's anything positive we can do to fix it. It involves not what? Not driving, not using energy, not traveling, not eating meat, not even having children, some people will say. It involves not moving backwards rather than forwards. And in fact, if we look at these Yale maps, I want to show you, use these maps to illustrate the first point. It turns out that if you ask people, is global warming happening? Not why, but just is it happening? The map looks a lot more positive. It's mostly orange here. And if you ask people, do you think that it will harm plants and animals? It's orange. People say yes, it will harm plants and animals. Okay. Will global warming harm future generations? You might think this is the same map, but it isn't. People say yes. Global warming, the majority of people say it's real. It will harm plants and animals. It will harm future generations. So distant in time. Will it harm people who are not you, but your neighbor? So other people in the US, we see a bit more blue here, but it's still mostly orange. And then they ask this question, will it harm you? Look at that. Will it harm you? All of a sudden, even places that totally agree with the science are blue. So in other words, we may agree with the science, but we don't think it matters to us. And if we don't think it matters to us, why would we try to fix it? This is the bigger problem. What's one of the main reasons we don't think it matters to us? Well, we think it's a distant issue. We think it's a distant issue in time, the future, not now. We think it's a distant issue in space, affecting people and things that are far away from us geographically, but not close. And we think it's distant in relevance. In other words, it affects, people who care about things like trees, but not me if I care about a healthy economy. And this is reinforced by the images we use. So I'm going to ask you a question and make sure you're paying attention. Ready? Go to polev.com/Catherine. And here's your next question. When I say global warming, what's the first image that pops into your head? If you're going to use two words, you have to join them with a dot here. So if you're going to say, maple tree, you need to say maple dot tree. So what's the first image that pops into your head? All right. The first image is ice here. Where is ice? Ice is up north. Oh, thank you. Somebody actually came up with the number one answer there too. Ice and polar bears. Now be honest, have you seen a polar bear in the real life in the wild? I'm sure a few people on this have, but not many of us, right? Why? Because they live far away. In fact, when I was asked to go to the Arctic with the polar bear scientists a few years ago, I said, well, I study what climate change means in the places where we live. So, as much as I would love to see the polar bears, I'm not sure that I'm who you're looking for. And they said, and I love how polar bears center here, they said, we study the polar bears because after them, we are next. But if the image is of an animal that few of us have seen in real life, or if the images of people's faces that we see are people who live very far away from us in places that we're not familiar with, of course, climate change seems like a distant issue. And not only that, not just distant, like we saw here, but then they asked one more question. And this question is very illuminating. They asked people, do you ever, this is the bluest map there is, do you ever discuss it? And look at this map. It is dark blue. There's one county, San Francisco. There's one county in Seattle, but everybody else is blue. So we might say, sure, I agree with the science. We might say, yes, humans are causing climate change. But if we don't think it matters, and if we never talk about it, how on earth are we going to ever fix it? And the fascinating thing is data has showed this to us. All kinds of different data. We've covered physical data so far. We've covered brain activity data. We've covered polling information data. So what's the real solution? The real solution, the first step to fixing climate change, is to start at the bottom. And what is the bottom? The bottom is we do not talk about it. We do not talk about it other than dumping information facts on people. But by talking about it, we can start to address the real problems, which are what? The real problems are we don't think it matters, and we don't think there's anything we can do to fix it. So what do we talk about? We talk about why and how it matters to us personally, not the polar bears in the Arctic, unless we live in the Arctic with the polar bears. And what are the positive things that we can do to fix it? And what do we use to do this? We can use data to do this, of course. So I want to walk through 4 examples here of how to not and how to, yes, use data to talk about these things. I want to talk about 4 different climate impacts. And the first one is sea level rise. I'm going to use a figure from the National Climate Assessment, which I talked about earlier, to illustrate how not to talk about it to people if you want to reach them. As a scientist, we love these figures, and these figures are very evocative, and they speak to us quite strongly. But if you show this figure to somebody of observed sea level rise and the future projections, it's really hard for people to make sense of it and to connect it directly to their own lives. So how could we talk about sea level rise? Well, if we just take a look at the headlines on sea level rise, here's where we're starting to connect it with why it matters to us. New data shows an extraordinary rise in coastal flooding. And what do you have there? You have hand-painted signs. You have somebody's car in a no wake zone. You have people's homes. Here you have a picture on a real estate blog of how Miami is raising the level of their streets by 2 feet to offset sea level rise. We have studies showing that just the Carolinas alone have lost $1.6 billion in property value, and along the eastern coast of the US, it's over $7 billion in lost value, so money. And then looking to the future, your Florida coastal home could lose 15% of its value by 2030. It's already lost 7% of its value today. So now sea level rise is coming home. It's no longer just these abstract colored global lines on a chart. It's relating directly to places that we've visited, places we might own property, money that we have, investments that we have, things that matter to us. So how can we tie this to data? Well, Esri does this. I actually went to the Living Atlas of the World, and just a second here. If you go to the Living Atlas on Esri and you type in sea level rise, You go down to 2 feet of sea level rise here. You click on the map viewer. I'm a little speedy here. It might take you a little bit longer. You click on the map viewer and you can actually start to zoom in on the coast to see the cities and even the neighborhoods. And if sea level rises by 1 or 2 feet, what is going to be underwater? Look at Miami here. This actually brings sea level rise down to the local level where we can see its impacts, using data to connect the dots between global change and its personal impact on our lives. It is incredibly powerful. And then we can extend this to saying, hey, we've got 700 million people in the low elevation coastal zone. We could be seeing 300 million refugees by 2100. This is why sea level rise matters. All right, example number 2. The oceans are warming. Now, here we have a few colored colored wiggly lines at different depths in the ocean, talking about ocean heat content in joules, 10 to the 22 exajoules. And most of us, we don't really relate to exajoules. That's not really a unit that we typically use in our everyday lives. So you might look at this, you might say, oceans are warming. Okay, why does that matter? Well, again, let's go to the headlines. We've got the Great Barrier Reef headed for massive death due to warming oceans. We've got toxic algae on the rise as the oceans warm. And we've got warm oceans driving hurricanes. Yes, hurricanes or cyclones or typhoons, as they call them in different places, they are fed by warm ocean water. And as the ocean warms, our massive coastal storms are intensifying faster. We don't see more of them, but more of them are stronger and bigger. So same number of storms, but of that number, more of them are stronger and bigger. They're slowing down, also dumping more rain on us. With Hurricane Harvey, we know that if the same hurricane had happened 100 years ago, and there was a very bad hurricane called the Galveston hurricane back in 1990, if the same hurricane had happened 100 years ago, it would have had 40% less rainfall, and it would have been 4 times less economically damaging with the same city as today. This is really bringing a warming ocean home with a vengeance. What about temperatures increasing? We can look at these figures from the National Climate Assessment again, showing our different future scenarios that we could choose and what the result will be in global temperature on the left. Each colored line is a different future scenario. The black line is the observations. Will we continue to depend on fossil fuels? Will we reduce our emissions somewhat? Will we reduce them a lot to meet the goals of the Paris Agreement? That's the green line. And this is very abstract. But when we look at it up close, and these are headlines from, as you can see, just the last week or two. Phoenix tries to reverse its silent storm of heat deaths. Actually, that one was from 2 years ago, but they're still struggling with that today. Heat records, weather patterns, climate change made the European heat wave 5 times likelier. Today, the headlines are that the Siberian heat wave from a few weeks ago would have been impossible without a change in climate, over 100 degrees Fahrenheit in some parts of Siberia. Wildfires are getting bigger because it's hotter and it's drier and they're burning more area. They're even pushing people to move out of the state because of them. What I actually do in my research is we increase the relevance of these global climate projections for these different scenarios by downscaling them to individual cities or states or counties or climate divisions. And when we do so, we can actually look at things like this. We can look at through downscaling here, the global models on the left and the downscaling through a regional model here is on the right. You can see that we increase the resolution of the climate model, but we don't just do it for scientific reasons. If you want to know more about it, I talk about it in chapter 4 of the National Climate Assessment. We don't just do it for scientific reasons. We do it because it enables us to say, hey, for Austin, Texas, for example, how many days per year have we already seen over 100 degrees? That's the black line. And how many days are we going to see over 100 degrees on average as we go into the future under a higher or a lower future scenario? So we can bring these global concepts down to the local level, and we can ask questions about things that matter, like days over 100 degrees, or the amount of electricity we're going to need to run our air conditioning in the summer, or the amount of evaporation we're going to have from our lakes. This is what matters. And then here's my last example, number 4, and this is heavy precipitation is increasing because warmer air holds more water vapor. And when a storm comes along today, there's a lot more water vapor for that storm to sweep up and dump on us than there was 50 or 100 years ago. So across the whole country, we've seen very significant increases, except in Hawaii and the Caribbean. But across the mid-latitudes in Alaska, we've seen increases in heavy precipitation since the 1950s, especially in the Northeast and the Midwest. And these maps might actually start to bring it home to us because we're starting to see regions, not just global here. But when we look at the headlines, it's so much more evocative. Epic flooding is the face of climate change. Massive rainfall just a year and a few months ago in the Midwest put millions of people at risk, damaging harvests and farming and infrastructure. Just the other day, China rushes to contain massive floods after record rainfall. So when we bring this down to the local scale, we don't just ask how will average precipitation change? We say, how will extreme precipitation change? What does it look like in my county? What does it look like in my watershed? What does it look like over my city? How will we prepare our impervious surfaces? How could we prepare greater water catchment areas to deal with the flooding? That's when this becomes personal, and we need data to do that. We know that weather and climate disasters occur naturally all the time. This is the number of weather and climate disasters that have caused at least $1 billion worth of damage since 1980. Texas is number 1 here. We know they occur naturally, but we know that a changing climate is exacerbating these risks. It's like we have a pair of dice, and we always have a chance of rolling a double 6. That's our natural risk. But over time, climate change is sneaking in and taking one and then another of these numbers and turning them into 6s and even the occasional 7. And so we're rolling events more frequently than we used to. And we're rolling even stronger or longer events than we used to too. And that's how climate change is affecting us in the places where we live. It is a threat multiplier. Why do we care about a changing climate? It's because it affects us. It isn't distant in time or space. It affects our water, our food, our security, our economy, our health. It affects us. So let me ask you one more question. Ready? Here we go. Give me one word. If you need to use more than one word, use a dot, okay? So if you have to say polar bears, use a dot. But don't say polar bears here. I care about climate change because it affects what? What does it affect relative to you? And again, if you are a polar bear scientist, absolutely say polar bears. But if you're not, what does it affect about your life? Yes, I love that health is coming up first, because if we don't have our health, what do we have, right? It's really brought that home in the pandemic. The pandemic threatens our health. It affects our loved ones, our children, our families. And that's exactly what climate change affects too. It affects everything, everyone, people, children. I like that somebody put my name there too. Yes, it affects me. It affects everybody. Everything I know, children, grandchildren, birds, forests, breathing, plants, weather, generations, snow, finances. Yes, it absolutely affects our finances, biodiversity, the economy, humanity, our future. I'm going to take a screenshot of this, don't worry, and I'll share it on Twitter because this is so true. Climate change affects everything, even snowmen. I saw that one there. As the Prime Minister of Dominica said, he said, to deny climate change is to deny a truth that we have just lived. We have lived it in the place where we are, and it has already happened. It is not in the future. It is not far off. When it comes to that piece of floating ice, we are the ones on the ice. So to conclude, these are the problems we have to tackle: psychological distance and solution aversion. How do we tackle them? Well, here's the interesting thing. Chris Chu, who's actually a researcher at my university, Texas Tech, he found that when we show people that climate impacts are not distant or far away, they are here and they are now and they are relevant to us. When we show people that, here's the crazy thing. It decreases polarization. It decreases it rather than increasing it. So the right data decreases polarization. The wrong data increases polarization. Isn't that fascinating? And here's how we do it. We need to connect this issue to decrease the psychological distance, and we need to show that there's positive solutions to address the solution aversion, the idea that we don't think we can fix it. We need to explain why it matters in the places where we live, as we've already looked at before, and then we need to talk about what real solutions look like, whether it's real solutions in industry with Walmart and Apple, whether it's real solutions in Texas, where we have the biggest army base in the US, powered by wind and solar energy, whether it's real solutions in, and this is another way to use the Living Atlas here, if you go to the Living Atlas and you type in renewable energy, and then it will come up with the renewable energy power plants across North America, then you click on Open in Map Viewer, and you get this tremendous layer showing the wind and the solar and the other renewable energy generation, the hydropower, across the whole country. If you zoom in on where I am right now in Lubbock, Texas, it's up there in the upper left-hand corner, there you can click right there, and I know exactly what that is because I drive past it almost every day. That's what it is right there. So you can show how we've actually got things going on in the places where we live. You can click on, for example, solar energy. Where are housing units already being heated by solar energy? And you can see, oh, Hawaii's looking really good. You can see across the south, there's a lot. We can zoom in on Phoenix, for example, and we can actually see, zooming in on Phoenix here, sorry, this is just taking me a little bit longer. We can zoom in on Phoenix and we can see that the most solar panels on people's homes being used for solar energy, the most solar panels are over there in the Peoria area and by the Air Force Base. Isn't that interesting? This is what data does. And they show that the number one predictor of whether people get solar panels is what? If your neighbors have them. So we can use data to show, oh yes, our neighbors do have them. So maybe we should get them too. We can talk about solutions in faith communities. We can talk about solutions like the coal mine of Kentucky going solar. We can talk about solutions like airlines running their flights off the LA airport here off biofuel. We can talk about solutions happening around the world as energy, clean energy is transforming people's lives. Where do we get this information? From data. We can use this data to show people that we're already fixing climate change. We just need more people on board. So what's the first step to tackling climate change? It isn't light bulbs, it isn't information dumps. It's talking about why it matters and what we can do to fix it, because this is what breaks that vicious cycle. Matthew Goldberg is a social scientist who's actually found that talking about climate change with family and friends helps people learn more about it. And the more we know about it, the more we talk about it. And the more we talk about it, the more concerned we are. And the more concerned we are, the more likely we are to act. So there really is a positive feedback loop where climate changes, we're worried, but here's where we break the pattern. Instead of dumping more scary facts on people, what do we do at this point? We share how it affects us and what positive solutions look like using data, but the right kind of data. And then people feel empowered. They feel like, oh, it matters to me, but there's something that we can do about it. So action results. This is the first step. Breaking the cycle of polarization by dumping scary facts on people, and instead breaking that cycle and talking about how it matters to us and what we can do to fix it. As Tally says, our brain is built to associate forward action with a reward, not with avoiding harm. So we need to reframe our message so the information we provide induces hope, not dread. That is how our brains are wired to work, and that is what will move us forward to fix climate change. How do we talk about these things? By explaining why it matters to us here and now, and positive ways that we can work together to fix it using the right kind of data. Thank you.
Thank you so much, Catherine. I hope there is tremendous applause going on virtually. I'm certainly, my dog and I are, so my dog woke up during your presentation and she's really into it. We can't thank you enough. We are going to try to go to some questions and answers now. And I've been moderating the questions. Over 70 questions have come in during your presentation, Catherine. So the engagement has been off the scale. As a result, we're not going to be able to get to all of them, of course, but we're going to take a few minutes to go through some of these questions. And thank you to all of you in the Science Symposium for your wonderful engagement and for entering your questions and also upvoting them. Mm-hmm. So I'm going to go with the questions that received the most votes. And given our time here, let's go quickly to the question that got the most votes from Catherine Clark. And she asks, what can I, or what can we, just one person, do to try to contribute to make the most difference to help mitigate climate change?
Absolutely. Well, I think, Catherine, that I might have already answered your question, because so often we feel like we have to take a personal action, like changing our light bulbs or recycling or eating less meat. And don't get me wrong, those are all very positive actions to take. But the biggest single difference that we can make is by showing people that climate change is not a distant issue anymore. It's not a matter of agreeing with the science, it's a matter of agreeing that it matters. Climate change is here and now, it matters to us, and there are positive solutions that we can do to fix it at every level. We can certainly take individual actions, but using our voice to advocate for change at our business, our school, our place of worship, our social organizations, our city, our state, whatever organizations, groups, or even social groups we're part of, using our voice is the single most important thing that we can do. And I actually want to share one follow-up resource with you. I know I've already given you lots of interesting homework and reading, but I want to give you one more here, and it is my TED Talk. Yes, I have a TED Talk, and you didn't get it today. You got a brand new talk I've never given before today. But let me share my TED Talk with you. I'll just share my screen with you for just a minute so that you can see it. And my TED Talk is literally called, people will think this might have been a setup with the first question, but it wasn't. My TED Talk is literally called The Most Important Thing You Can Do to Fight Climate Change. And my answer is talk about it. Because if we don't talk about it, why would we care? And if we don't care, why would we fix it? And as Matthew Goldberg showed in that last slide that I shared, Matthew Goldberg's work shows that talking about it creates a true positive feedback loop. Remember, where climate changes, we get worried, but we don't scare people. We say, hey, it matters. Let's support solutions. Let's call our elected officials, our city council person. Let's call our representative. Let's call them and say, hey, we care about it. We want solutions. Let's talk to our place of work and say, hey, what does our carbon footprint look like? Let's step on the scales. Let's see how we could reduce our footprint and how we can communicate to people why this matters. And that's where Esri is actually perfectly poised, because Esri can not only take personal action, but communicating to others why climate change matters and what we are already doing to fix it is so powerful. And I hope that you saw through those living story maps and storylines that I showed you that Esri has a lot of the information we need to talk about. Thank you.
Great. The questions just keep pouring in, but the upvotes keep pouring in as well. So now Sarah LaRue's question has been upvoted as the next most popular. And her question is multi-part. Are there studies that show beliefs based on age? Is the gray bar that separates opinions on climate change smaller in younger generations? And are there any good resources for the younger generation to get the right kind of data as a good base of knowledge?
Yes, you are absolutely right, Sarah. You hit the nail on the head. There is a huge age gradient among conservatives. Not so much among liberals. Among liberals, it's pretty even across the spectrum, but among conservatives, there is a huge age gradient. In fact, I'm a scientific advisor for an organization called Young Evangelicals for Climate Action. And I realize in the US, where evangelical is more of a political term than a theological term, that may surprise people and it might seem like an oxymoron. But there's over 30,000 young evangelicals around the country who are actively advocating for clean energy standards, for climate solutions, for climate resilience. And when we talk to young people really across the world, they are the ones who are most concerned, no matter where they come from, no matter who they are. And we see that in the children's climate strikes as well. The kids get it. And part of why they get it is because their brains haven't been exposed to as much contradictory information, which increases the polarization over time. So there's actually a correlation between our age and what we think about these things because our coping mechanisms have kicked in. Whereas with the young people, they haven't kicked in yet. So they get the information, they get it immediately. I saw a question kind of fly by too about why isn't teaching climate change mandatory in school? Well, according to the Yale climate opinion maps, they asked people, do you think it should be taught in school? And everybody said yes. So even people who don't think it's real think it should be taught in school. They might not think the right thing should be taught, but everybody agrees it should be taught. And increasingly, some cities, states, and countries are agreeing. Italy was the first country to make it mandatory to study climate change in school. It doesn't have to be in science. You can study how we talk about it and think about it in English. You can study it in geography. You can study it in physics and chemistry. You can study it in economics. You can study it in almost any area. And then New Jersey, I think, just made it mandatory. I actually wrote the curriculum for the grade 10 unit on climate change for the province of Ontario a number of years ago, and it's been used in various places across Canada too. But I agree it should be mandatory because shouldn't we understand one of the biggest issues that's affecting the future of our civilization as we know it? The planet will survive. The question is, will our civilization survive? And we don't yet know the answer to that.
I've also been trying to field some of the questions and answer them right away in the Slido, Catherine. And one of the questions that's come across is what can we do with GIS? And so I have pointed those questioners to our science portfolio, which I showed at the beginning of our symposium, which has all kinds of use cases. There are learn lessons there. There are web apps. There's story maps. There are links to the Living Atlas that you explored yourself, Catherine. So there are all kinds of things there on the science portfolio. And those links are in the slide deck that I shared with you at the beginning. And then of course, all of you are going to get the recording of this presentation. Someone had the great comment, I want this presentation for GIS Day in November. And I responded to that questioner, show this video. Okay, let's go to one more question. I think we have time for a few more. So now Roberta Burns, her question has flown to the top in the polling. And her question is, our response to climate change in this country seems to share similarities with our response to COVID-19. Polarization seems to be increasing, response is lacking, and the problem is getting worse. Do you think effective communication about these two topics is comparable?
Well, I don't just think it, I know it because I've been looking at the polling data. And organizations like the Yale people who do the climate opinion maps, they've been polling about COVID also. And here's what we see. It's very different depending on what country you're in, but there is definitely a tendency towards more conservative people having more of a tendency to say it isn't real, it doesn't matter to me, the risk is low, there's a high psychological distance between me and this issue, it affects those people over there, not me. And there's a strong resistance to taking actions like wearing masks and quarantining, depending on where we fall on the political spectrum. So unfortunately, we are seeing the exact same things play out, where originally very few people thought this was a problem, and not until it was staring us in the eyeballs were we willing to act. And when we got to the point where we were willing to act, political divisions were making something as simple as whether we wear a mask over our face an issue of contention. When study after study, besides our own common sense, tells us that yes, it does make a difference. Not only does it protect other people from us, it actually protects us from other people as well, studies have shown. So sadly, this polarization is really the root out of which all kinds of shoots are growing. The climate change polarization, the COVID response polarization, all kinds of things are coming from this root problem of the fact that we've been bombarded with too much information. It's too customized so that we can live within our own bubbles. We feel overwhelmed, so we start to draw our tribal lines even more strictly. And what that does is it divides us rather than unites us, just when we most need to be united.
Okay, we still have some time here.
We can do this.
Wow. I don't know how this one flew up to the top. Is it just me, or does Dawn have an awesome Star Wars collection going on behind her? Oh, sorry, that flew up to the top. It's not a question. Yes,
and it's Lego too. I love it.
Okay, the next upvoted question comes from, and thank you, Andrew, for that compliment. The next question comes from Gary Hallbauer. What is the action that will have the most immediate and most dramatic impact at reducing carbon dioxide levels?
Ooh, so here's the thing with our carbon emissions. They don't come from one thing. They don't. It would be great if they did, but they don't. They come from almost everything. So they come from transportation. They come from heating and cooling our homes and our buildings. They come from industry. They come from agriculture. They come from our diet. They come from all across the spectrum. So the bad news is there's no one silver bullet that will fix it all. But the good news is that there's a lot of silver buckshot. There are a lot of solutions that, depending on who you are and where you're at, you can implement. And your speaker from 2 years ago, you had John Foley? Yes, 2 years ago, you had John Foley, who is now the director of Project Drawdown. And I want to direct you to drawdown.org. And I'm going to share my screen with you very briefly so that you can see it. Drawdown.org, because it has the most amazing set of solutions. They have solutions in every sector. They've got electricity, food and agriculture, industry, transportation, buildings, sinks, which is pulling carbon into the soil, coastal and ocean sinks, and health and education. And if you click on this, click on electricity, for example, it's got all of these different solutions here at the bottom, everything from insulation, good old insulation, to high-tech microgrids. So there's no one single action, Gary, but there are a lot of actions that we can take depending on where we live. And for us personally, if we want to know what's the most important thing for us to reduce our carbon footprint personally, in addition to having conversations about it, of course, step on the carbon scales, measure your carbon footprint. For me, it was my travel. And so that's why I've transitioned over 80% of the talks I give to virtual talks, 100% now, obviously. And when I travel, I only do so when I have multiple events in the same place to keep my carbon footprint down. Thank you.
Thank you so much. We've gotten now close to 110 questions. So we're going to have to close the questions now because we have a bit more housekeeping to do. And Catherine, we'll have to put our heads together to see how you would like to address these questions that we didn't get to, because they are some amazing questions. Just a reminder for everyone, we have recorded this presentation. The presentation will be available to you as registered attendees soon. And then we are going to make the presentation available for the entire world later on in the summer. And that includes the question and answer session. But I want to, let me see if I can share my screen, because we can also continue this discussion on GeoNet, which is our Esri discussion, community discussion forum. And so you see the link there. We can set up a discussion, discussion page for you to continue with these questions and to continue to discuss among yourselves. We cannot prevail further upon Catherine's time with her busy schedule, but we'll figure out a way for Catherine to get feedback to you on your questions. So stay tuned to that. And I will also announce that on GeoNet and also via social media. Also a reminder that if you did not see the link to get your pre-release copy of GIS for Science, which has some wonderful climate change resources in it as well. That is the link in the light yellow that's just below the GeoNet link. If you didn't get the link to the flip book, that is there. And then if you didn't get the link to my slides, that is there as well. Catherine, how about your slide deck? Is that something that you would be willing to share in a PDF format, or how would you like to handle that?
Yes, we're going to share some of the slides with links to the resources so you can learn more from the resources I cited. And I want to direct people finally to Global Weirding on YouTube, because a lot of the questions I'm seeing here are actually answered by Global Weirding episodes. So check
Yes.
out Global Weirding, like our Facebook page, because we're going to be going live with once a month questions on Facebook every month starting in September, where you could ask whatever question you want and I answer it live. So like our Global Weirding Facebook page, check out these questions here. And Dawn and I will put our heads together and figure out how can we answer a few more of these questions, maybe on Twitter, maybe on some type of social media, so you can get those answers. Thank you.
Yes, fantastic, Catherine, because someone asked, where can I get more of Catherine Hayhoe? I said, well, go to YouTube, Global Weirding. Catherine, this has been so tremendous. And what we normally do for the Science Symposium is that we give the keynote speaker an award. And I usually hand that, it's a beautiful acrylic award that I give to the speaker. Of course, we can't do that. So your acrylic award will be on the way to you very soon in recognition of this tremendous presentation that you've given and the engagement with the audience. One of the comments was that this presentation was one of the best this person had seen at the UC this week. So we're always happy to hear that. And also, especially for you, I have a limited edition Toy Story 4 Canadian mini character that I'm going to send to you as well, because Catherine is a gift to us in the United States from Canada. Now, do I share my screen? Let me share my screen one more time. And I think that's it. Yeah, that's it. We are done. So we're going to end the session a little early, because we want you also in the Science Symposium audience. We would like you, if you have a few more minutes, to attend the Esri UC closing plenary with Jack Dangerman. I'll be in that plenary as well, along with the other directors of Esri. And so that will be convening at 8 o'clock Pacific time, the top of the hour, whatever time zone that you're in. So Catherine, once again, thank you so very much. This was a tremendous experience. It was a lot of fun. And we really, really appreciate you participating with us in this Science Symposium. And we'll look forward to working with you. Our team at Esri will be working with Catherine throughout the next couple of years. And so we look forward to that as well.